Hey everyone, I just want to cover that last problem we were working on regarding that parallel and series circuit. And I want to do it just by carrying, I want to do the same thing, but I just want to be really clear about it. And I also want to carry another sig fig or two because I noticed that our observed values were slightly off of our predicted values. And usually in electricity, you're within a couple percent. We were outside of my observed values. So when I reran the numbers using another, carrying another sig fig, which we should have done, then things ironed out a bit, right? And so here's the circuit, the same one we saw earlier, with the 47 ohm and the 33 ohm resistor in parallel, right? And so the first thing we did was we said, okay, well, we want the current in the circuit, right? The current through the whole circuit, the total current, will be V over R EQ of the whole circuit, right? And we measured the voltage as 11 volts. We just need the resistance of the circuit. And the first thing we did was simplify this parallel element right here, right? So this thing here has a resistance less than either of those, because if it was just a 33, the resistance would be 33, but it's easier than that because this is another gate open. Right, so 1 over Req is 1 over 47 ohms plus 1 over 33 ohms. And so Req of that part of the circuit, just the parallel part of the circuit, is 19.4 ohms. Right? And so the Req of the whole circuit, well, let's see, the current hits that 33 ohm resistor, and then it hits the equivalent of a 19.4 ohm resistor. So it's just 33 ohms, 33 ohms plus 19.4 ohms from the purple circled parallel element. And 33 plus 19.4 is 52.4. So this circuit has a resistance of about 52.4 ohms. Okay, so 11 over 52.4 ohms, I do believe is 0.21. We just called it 0.2, and there's where we went wrong. 11 over 52.4. See, I'm seeing 20.99. No, sorry, 0.2099. 0.2099. 0.21 amps. Okay? Now that's the current through the circuit. So here comes I1. I1 is full current, is 0.21 amps. That current is incident upon or goes through a 33 ohm resistor, and so the voltage from A to B, the voltage drop A to B across the 33 ohm resistor, the voltage, if you put a voltmeter there, it should read V equals I times R, 0.21 times 33. 0.21 times 33. I'm seeing 6.93. Right, so I see a V here of a 6.93 volt drop. And earlier we called it 6.6 because we didn't carry that 1. Right, so we're seeing a bigger voltage drop here. So now we're down, so if this is the 11 volt position, right, that's positive 11 if that's 0. Right, so we're at the 11 volt position, 11 volts, and we just dropped 6.93, minus 6.93. We are now at the 4.07. So the voltage here, the difference between here and here, this is 0. This is 4.07 volts, if that's 0 volts. Right? So we're going to drop across these two elements here, have 4.07 volts across them. Okay. Now I want to double check that. Here's another view of that, which we did not do. Let me grab a different pen. You could also do this. Well, let's stay in purple, right? That's the purple part. Right, so the purple part, we could also say this. What's the voltage drop across the purple part? V purple. Well, it's I times R. What I? Well, all of it, right? 0.21 amps. So V purple is 0.21 amps. Let's see if we get 4.07 for the voltage drop here. 0.21 amps. and it's incident upon an element that has a resistance of 19.4 ohms. 19.4 ohms. So when I do it this way, let's see if I get 4.07. Right, so 0.21 times 19.4, 4.07. So either way, so there's two ways to get the voltage. You can say, well, you can recognize it's going to be an 11 volt drop all the way around from, well, from here, not all the way around, but from the high point to the low point will be an 11 volt drop. And if you figure this out, then this is just the rest of the drop, which is what we did first. Or you can say the voltage here between here and here is I times R. Well, how much current enters? All of it. 0.21 amps enters, right? And then enters the parallel element. And multiplied by the parallel element's resistance, we also get 4.07 volts. Okay. Now, what about the current through the 47 ohm resistor? All right, so let's check these currents. The current through the 47 ohm resistor. So I'm just going to write I47 is V over R. What V? The voltage across the resistor. Well, that's 4.07. We checked it two different ways. Equals 4.07 volts divided by the resistance of 47 ohms. And so that should be a current of 4.07 divided by 47. I'm getting 8.66 E negative 2. 8.66, 0.087, right? And we showed that before to be 0.094. So we're expecting a little bit less current there, like 0.08, 0.09-ish, shy of 0.09. Right? And the current through the 33 ohm resistor will be V over R, will be the V across the resistor, which is again our 4.07 volts. This resistor here, the 33 ohm resistor, has 4.07 volts across it, and it's got a resistance of 33 ohms. And 4.07 over 33 is 0.12, 0.12 amps. So these numbers, and before what did we have? Oh, we had 0.13 before. Not much of a difference, really, just a tenth. Oh, sorry, 100th. Not much of a difference there. But I just wanted to lead you through it in one quick little video here. This is how you attack current through resistors. You find the voltage across them first, and then the current through it is just a function of V divided by R for that resistor. So we can now compare these numbers to the pictures I took of the actual numbers. And of course, this is all assuming that this voltage of 11 volts is true. And with these old meters, that's hard to know for sure. But this is definitely the approach, and I hope this helps with your Schoology assignment, which I would like you to get done also during this break. It'll only take you 15 minutes or so. Just a few quick questions. Alrighty, that's it. Have a great break. Talk to you soon.